welcome. Today, we'll be talking about this equation right here. The absolute value of x squared minus 15 is equal to 2x. So, first things first, let's talk about what the modulus function is. The absolute value of x is going to be, x if x is greater or equal to 0, and negative x if x is less than 0. Okay, so let's try some examples. The absolute value of 4, what is it going to be? Well, 4 is greater than 0, so that's just going to be 4. What about the absolute value of negative 2? Well, negative 2 is less than 0, so it's going to be the negative of negative 2, which is equal to 2. If you notice, the output or the result that we get from a modulus function is always going to be greater or equal to 0. This is important information because in this case, we have an output of 2x, which means that 2x must be greater or equal to 0. So x must be greater or equal to 0 later on when we solve the equation. Now, from this machine right here, this definition of absolute functions, what we know is that this x squared minus 15 can be two possible cases. The positive version of 2x or the negative version of 2x. So we need to consider both of these cases. Let's consider when x squared minus 15 is equal to 2x, where 2x is greater than or equal to 0. This will fulfill the first branch of the definition of the modulus function. For this inequality, this is just the same as this actually. Okay, now let's talk about the other side. What about this branch? Well, it means that x squared minus 15 could be equal to the negative of 2x, where negative 2x is less than 0. These are two possible cases. They cannot be fulfilled at the same time for any value of x, so we use the word or to connect these together. Now, let's get solving. We are going to subtract 2x on both sides, so we get x squared minus 2x minus 15 is equal to 0. And for the blue equation, we are going to add 2x on both sides, so we get x squared plus 2x minus 15 is equal to 0. Okay. Oh, just by the way, for this inequality, it also solves back to x greater than 0. Now let's factorize the red equation. What factors of 15 when added, negative 15 when added together, give us negative 2? Well, we know negative 5 plus 3 is negative 2. So x minus 5, x plus 3 is equal to 0. Now, for the blue equation, what factors of negative 15 give us positive 2? Well, that's going to be 5 plus negative 3. So, x plus 5, x minus 3 is equal to 0. Okay. Now, you can solve for x. We know that x minus 5 must be equal to 0, or x plus 3 is equal to 0 for the red equation. For the blue equation, we know that x plus 5 is equal to 0, or x minus 3 is equal to 0. Okay, so from these equations, we can pretty much find the value of x. So for the red equations, x is equal to 5, x is equal to 5, or x is equal to -3, or for the blue equations, x is equal to -5, or x is equal to 3. So is that our final answer? Hang on. Looking back, we established that x must be greater or equal to 0 for the red equations and must be greater than 0 for the blue equations. However, we do see that x equal to -3 is an answer to the red equation, and x minus 5 is an answer to the blue equation. These cannot be the answer because x must be greater or equal to 0. Therefore, we need to reject these values because x must be greater or equal to 0. Same over here. In this case, it's more for x greater than 0. So we are left with two possible answers. So therefore, x is equal to 5 or x is equal to 3. And that is our final answer.